So C# is easily the most beautiful note in existence. And beyond that, I just want to really take a minute to think about how many people sneeze, fart, cough, and all that good stuff on a plane ride where you're trapped inside of that tube with all the same air the whole time. All right. So that was fun. Gross. All right. Let's check it. I want your guys' help. Now, I'm going to phrase this question a little bit differently, okay? But I promise there's a reason to it. In the end, since this is example C, we're just going to do what? Divide. That's right. Okay, is that what you said? Okay, well.
I said example C.
Okay, so example C, your guys' was to divide, right? Like that's what we're doing. I'm going to phrase this question differently, but I promise we're just going to divide. So here it is. Is 2x plus 3 a factor of, and we'll just say 2x cubed plus 3x squared minus 2x plus 3. Now, I've already kind of hit on the fact that it's going to be division. Why would division be the answer to solving this question? How do we use division to verify or check if it's a factor? If it's a factor, the what is 0? You said 0. The remainder is 0. So that's all we're checking, right? Let's just do the division and see if the remainder is 0. Now, what is the divisor in this problem? 2x plus 3, and that goes on the outside. So here it is. What is the dividend? That mess, right? Are we missing any powers? X to the 3, 2, 1, and 0. Okay, we're good. So we'll just write it here. 2x cubed plus 3x squared minus 2x plus 3. Now, Deck, if you haven't started, I can't tell where you're at. I don't see. Do you have the same thing that I have written? Okay. Your question at the start of class was how do we get to the second line, right? And we're going to see that right now. I'm going to switch colors for each line. You guys don't have to switch colors, obviously. I'm getting better at it, maybe. I don't know. Who's queen? 2x. This is the most important. And the very first question when I start this is I need to multiply 2x by something to get what? I need a 2x cubed right here. What do I multiply x or 2x by to make it become a 2x cubed? Should I write it here? No. Where? Above the x squared term. So we'll just do x squared. Now, what happens next? Multiply. So we distribute in, and we do both of these. And I couldn't tell if that was a I'm not sure or... Okay, so check it out. We distribute. And I'll keep these lines here for this one. And let's check. What's x squared times 2x? 2x cubed. What's x squared times 3? So here they are. And what do I do with them? We subtract. Now this one's going to shake out weird. And there's a couple ways we can go through it. I'm going to do it just like we did yesterday. This one's gone, right? That's the whole point. What's 3x squared minus 3x squared? 0. And it's going to look silly, but 0x squared. And then what else do I need to do? Indeed. So this question, again, it's going to feel silly when we do it. But 2x times what gets me a 0x squared? 0x. Now, in my actual answer, do you think I'm going to write 0x? No, but it's helped me keep stuff straight. So let's distribute. And this one feels silly, but it's 0x squared plus 0x, right? And I subtract. And what do I get? Negative 2x. And we drop it straight down and plus 3. So sometimes, and I'm guilty of this, I was guilty of it this morning, not here, obviously. If I get a 0 here, I will typically just drop the next two down and keep working. Now, this allows us to make sure that we see it. Don't erase anything of yours, but I'll show you what I mean. Did it feel weird to write 0x squared here to anybody? Okay, don't change yours. I just want to show you guys. If we did that and we said, hey, I noticed that everything fell out because it's just 0x cubed and 0x squared. I have two terms here, right? I would then drop 2 down to make sure it matches. And I just want you to check. When I drop 2 to guarantee I get the same things, I wind up with a negative 2x plus 3. When I skipped that line, or when I didn't skip it, what did you guys have written? hey, it's the same thing, right? Like we get the same thing, and I'm just going to pretend like I didn't do it. I just don't have a 0x. Don't erase yours. Like we'll see it's the same, and it works out. What's the next question I'm going to ask myself? 2x times what makes that? -1. Should I write it here? No. So even if I don't have the 0x, does it still work out? Yeah. Now, I want to encourage the placeholders, but it's not really a placeholder. It's just one line. Okay, when I do that, I get -2x minus 3. And something wonky happened. What did I write down wrong? Too late now. Is that a -3? That's a plus, and that's a plus. So nothing's wrong on ours, right? I just wrote it down wrong. That's okay. Okay, what's left over? 6. And I'll put the parentheses because if we don't distribute it, we get wonky with it. Okay, so when we get -2x plus 3, remember we go back to our queen. Great question, by the way. What do I multiply the queen by? 2x to make it -2x. I'm not sure because I don't want to give you the answer. What times 2x gives me -2x? 2x times 0 is 0, isn't it? So what do I have to multiply by to change the sign? So -1 times 2x, would that give me the same thing? I think you're thinking too hard about it. 2x times -1 gets me my -2x. Because I took out the plus 0x that you have. Okay. Looking at this, what's the remainder then?
6.
So what's the answer to our question? No, this was not a factor, and I did have a typo right here. That's okay. Okay, so therefore, no, 2x minus 3 is not a factor. Okay. Yell, I don't think that answer really cleared stuff up for you. Is that true? Yep, I remember it always defaults to this times what gets me this thing. Yep, and I think that you were just got goofed up somewhere. But it's not your math, it's just a goofy afternoon thought. Okay, doable. Okay, here's the deal. I'm going to look at the examples that we saw yesterday, and we're going to rework probably A here in just a minute, okay? We're going to redo A from yesterday, but we're going to look at the second half of this section. Okay, long division. There is a time and place for it. The good news is it's not every time, every place. There is another way that we can do this that works super duper nicely, and it's like our shortcut. Just like when I use grouping, it's just I can use grouping with the leading coefficients 1, and we saw there's a shortcut with it. This shortcut is much more specific, and we're going to jump in. It's still the same section, so we're still in 3.4. We're just going to finish it today. The first half of our section was long division. Okay, do we need to do any more long division examples? Okay, so today we're going to start talking about the second side of this. We're going to call it synthetic division. Not synthesis, synthetic. And immediately, when you guys see synthetic, what does it make you think of? So synthetic silk or synthetic down is a pretty common place to see it. Do you guys know what, like if I get a down coat, and have you guys ever heard that, down? So it's a material that goes in coats and stuff, or old pillows. You used to have down pillows. Back in the day, what were pillows made of? Feathers. And if you don't know this, goose feathers are really soft. It's called goose down is what it's called. It's like the fluff that comes off the end of a feather. Okay, so when you have like a puffy coat, you can buy it with goose feathers or goose down inside, and it's really warm, it's really nice, but if it gets wet, it doesn't dry. Like it's hard to dry out. That's why goose down's not huge, like still. So they make fake or artificial down as well to put in coats, and it's called synthetic. When you see synthetic, I don't think of materials like that. I think of oil is what I think of. Because when I go to buy oil for my car, I can either buy regular oil or synthetic oil. Synthetic is not purely just petroleum products that have been refined. There's additional stuff done to make it like man-made. It's artificial. Now, what this essentially does then is it pretty much just means fake division. Fake division. Now it winds up being super valuable for us, and we're about to see why. For this, we need the steps. And what I think I want to do is we're going to work an example, and at the exact same time, I'm going to color code it, and we'll get the steps lined out all the same. So I'm going to recopy our problem from yesterday right here. We're going to rework this problem, but instead of long division, we are going to do it synthetically, and we'll just see what shakes out. So we are going to have an example and the steps all in one. So let's go over here and find where it was. And we're just going to jump right in with a new example, and steps. And that's just where we're jumping in. So on A, here's our problem. And it's going to annoy me, so I'm going to rewrite it so that stuff lines up because it's going to bug me if I don't. Okay, while I rewrite it and while you rewrite it, maybe I should have said so a minute ago. Was I missing anything? 3x cubed. How many x squareds? Good. We should probably write it. And not probably, we will write it. 0x squared minus 5x plus 10. And we're dividing all of this by x minus 1. Okay. Now, I know we already did the problem, and you have it. Hopefully, it's on the exact same page. But I want you to see the value in this. Is long division super hard? It's kind of time-consuming, though, I think. Okay. While we're looking at this, here's what we're going to do. For synthetic division, we're going to look at the steps first. So step 1, and I'll just do this first one in yellow, and these are in no particular order. We need to verify or check that the divisor is of the form x minus k. Now, it has to be in this form. And I'm going to add one more little piece to this just so we can see it. But is this x squared or x cubed or x to the 5th when I write x minus k? Sorry. That's x to the what? 1. It's just x. Not an x squared, not a negative x. It's just an x. Now, more so, what is the leading coefficient or the number in front of this x? In this one. Okay. This has to be the case. We have to have a 1 in front of this. Now, it'll just look like x minus something, but there's a 1 on this one also, right? Okay, so that's what we do. Once we knock this out, there's like 3 things in this one. Can I write like a caveman? As long as it's understandable. Okay, identify, and I'm just going to use ID, K. So over here, and I'll switch colors to green, and you don't have to change anything, but we'll say on my step 2, it is ID the value of K. That's part of this. What is K in our problem? What are we dividing by? X minus what? So good, and you just said x minus what number?
1.
K is 1 in our problem. K is 1. Everybody all right with that?
Yeah.
Beyond that, we need to draw. There's going to be 3 things in this. Identify K, we've done it. This one, you'll have no idea what to do at first. We're going to draw our synthetic box. And put K outside and the coefficients of dividend inside. Okay. You don't know what any of well, you know what some of it means. We've identified the K as 1. You have no idea what it means to draw a synthetic box, but we're going to do that. And then we're going to put 1 outside of this box, because that's K in this problem. And then we're going to put the coefficients inside of our synthetic box. Now, if you need it, add it. But again, it's always up to you if you write it or not. I want to make a warning here, because this is where people get goofed up. Placeholders, just like with long division, if we're missing a power, what do we need to do? Yeah, we have to have placeholders if we are missing powers. You have to. Now, long division, you might be able to sneak by and get it right, without them. You will not with synthetic, like guaranteed. You will not get the right answer. So now the question simply becomes, well, what does all this mean? We normally draw division, and you don't have to draw this one, but this is what the division symbol normally looks like when we're doing long division, right? We're going to flip this straight up, like flip it. Here it is. Here's my step 2 in green. We're going to flip this. This is what I consider my synthetic box. Do you need me to turn off a light? Are you getting glare, Jade? Are you getting a glare somewhere? Okay. There's also a wonderful seat on the other side if you'd like it. You don't have to move. It's up to you. Okay. What goes outside of this box?
1.
Good. The value of k, a 1. I'm going to put it right here. Now, when you write these, we're going to have 2 different rows in here, just so you know, 2 rows. The first row is of all that we're going to put right now, the coefficients of the dividend. What are my coefficients of this thing? What's the leading coefficient of my dividend? 3. So I'm going to put a 3. What's the next coefficient? 0. The next? -5. And the last? 10. Notice I put the 0 when we were missing, and I put the sign on it if it's anything but positive. If you want to put positive on each of these, you can. I don't, but you could. +3, 0, -5, and +10. Everybody okay with what we've done so far? Now, the only thing that is going to get weird is if this is x plus something, we're going to have to switch a sign. Like, it's going to be weird, but we'll see one of those as well. Okay, you guys ready to do the actual synthetic part? And this first one will take us like 5 to 10 minutes, but after this, you'll see it's a huge time saver. Here's our big step 3, and it's just going to keep getting added to this, just so you're aware. Okay, we are going to drop the leading coefficient from our box. So drop LC, which is the 3 in our case, straight down. Now, I still encourage like it's hot, but we're going to drop it straight down and then just add like it's hot if you want to. What I mean by that, and I'm going to wait till everybody has this because we're going to do a couple things. We're going to drop the leading coefficient straight down. I'm going to physically draw the arrow and drop it straight underneath. Okay, again, we're learning a completely new way to do this, but it's so time saver. Okay, have I lost anybody yet? Here's the weird part where there's no nice way to say this. When we look at long division, just regular old number long division, whatever I write here, I multiply by this, yeah? Whatever I write here, I'm going to multiply by this. So what I have in my directions, and if we need to change this, we can. We're going to say, now we're just going to kick it off. We're actually doing the division. We dropped it straight down. We're going to multiply k times the leading coefficient and write the product, which is just the answer to whatever this is, product under second coefficient. Okay, so right here, what I want you guys to do, we're going to add something else, but I want to see if this is clear enough. What am I multiplying here? So I'm going to multiply 1 and 3, right? Does everybody agree that that's what this says? Multiply k times the leading coefficient, and it happens to be this one that's already fallen. I can multiply those. Where should I write? Like, I know that 1 times 3, when I multiply them, is 3. Where do I write it? So what does that mean? So move up from here and go over. Can I write a 3 right here? So this is where the directions get ugly. We multiplied this times this, and we wrote it right here. Okay. Now, I don't normally have these marks because it makes it look ugly, but this times this, and we write it right here. Now, I'm going to change colors just so I can see it. We're going to add straight down okay, we're going to add straight down, write the sum, which is the answer to whatever that addition is, in second column below synthetic box. I'm just going to call it synth for synthetic box. And I want to see the same thing. Are these directions clear enough that you can tell me where to write it? What am I going to add? Oh, wait, sorry. I always go too fast. All right, Declan, what am I adding, do you think?
0, 2,
Good. What's 0 plus 3?
3.
So check it out. We're going to add straight down. And we won't do all this stuff like regularly, but we're just going to make sure we can see it all here. 0 plus 3 is 3. Okay, this last part, if this is clear enough, I love it. If it's not, we'll keep going. I'm going to say add straight down, write the sum in the second column below the synth box, and repeat. What do you think I mean when I say repeat?
Multiply by 1.
I'm going to take now 1 times, and it just so happens to be the same number, but I'm going to take this 1 and multiply it by this 3, and I get what? And where do I write this?
Negative 5.
There's a 3 right here now. And now it just keeps kicking. And we just keep doing this until we can't anymore. What's negative 5 plus 3? So I'm going to switch to a different color now just because. Negative 2. And what am I going to do with this negative 2? I'm going to multiply it by 1. And I'm going to write it where? So what's 1 times negative 2? Negative 2. And then what am I going to do with these? Add. Now there is one mark here that I do differently. I do a lot of stuff differently than your book, and I'll show you guys that. But I also typically add this little bar. Now, I'm going to scroll to the left. What we just got were just numbers, right? 3, 3, negative 2, and 8. Does that feel okay? Like, was that super hard to do? Now, you might not really understand what happened, but I'm just going to scroll over here. We just got, what were our numbers that we got? 3, 3, negative 2, and, This is the same problem we did yesterday. We just got all the same numbers. Okay, here's the hardest part. And like none of it's really truly hard, but if you're going to get goofed up, this is probably where it's going to happen. Our very last step. I'm going to write it here and it's going to look stupid, so sorry about that. Step 4, just so we can see it all up here. We now have the coefficients of our quotient and our remainder. We get coefficients of quotient, and we're going to pause here for just a second before I even say anything about the remainder. Okay, when we're doing this, we're only ever going to use synthetic division if we are dividing by something linear. And all I mean by that is x to the power of 1 minus some number, or plus, but I don't really care about that part. If I took originally, and I looked at the problem, the dividend was x cubed, right? Is that true? The dividend was a degree 3. Was it to the 4th? Degree 3 is the same as saying it's x cubed, something x cubed. That was our original. Something x cubed divided by x. It was x minus 1, but it was x, right? If you took a cube and divided it, x cubed divided by x, what does it give me? And I'll write that here because that might be a harder question just to talk about. But without everything else, we just did x cubed and a bunch of other stuff, and we divided it by x plus something else also. What's x cubed over x going to give me? Is it to the 4th? Is it to the 4th or is it squared? It's x squared. One of them divides out. If you want me to convince you of that, I can. Do you agree that x cubed just means this?
Yeah.
What's x squared? Or x? It's just x? How many cross out?
Oh, I thought you were adding that together.
So they subtract if it's division, they add if it's multiply. But do we agree that x squared is what's going to shake out? Okay, what we get out of this are the coefficients of our quotient, starting with degree 1 less than dividend. It'll always kick down 1 because we only do this if we're dividing by x to the first power. 1 less than dividend. Now, this is the wordiest thing that by far the wordiest way I've ever done it, but I'm trying to really lean into feedback that I've gotten. As we do this, I just want to apply it in this situation. In our problem, we had x cubed, and we divided it by x, and it took us down to x to what power? What's 1 less than a cube? Squared. So check it out. I'm going to write my answer right here now. We have a 3, and it's now x to the what power did we just say? Good. 3x squared plus 3x minus 2. And then what does this represent? And how do we write the remainder? Good. If you look back at example A yesterday, is this the exact same thing that we did? 100%. Now, it took a long time to do this just now because we're writing out all this stuff. Do you think it's going to take a long time to do every time? Probably not. Let's do another one. Okay. Before we continue on, any part of this that I've lost you?
The step 4, the degree.
So for this, do you agree we started with x cubed?
We did.
Like if we look at the very beginning of the problem, it was 3x cubed. And if we divide it by x, and every time we only divide it by something with x, it's always going to just go 1 less. Okay, so let's really exemplify that. This one, I want you to try on your own. We'll just see if it goes, how it goes. So on B, let's see, how ugly do we want it?
Not really.
Okay, we'll do super ugly. It won't really be, just so you know. Let's try the following. I want to do, sorry, I'm trying to figure it out. Sorry. All right, here we go. On B, we are going to do the following. We have 3x cubed plus 4x squared minus x minus 2. And we're going to divide this bad boy by x plus 1. Now, there's really only one spot that I'm worried about anybody making a mistake here. Before you just do the whole problem, we're going to agree on one thing. I want you to quietly tell me what, write it down on your page. I need to know what k is. That's like the very first thing that I need. What is k in this problem? And if we can answer that, the rest of it's going to come easy. And I'm going to be really nosy. I'm going to physically come and look. What's k? I disagree. What do you think it is? K? K? What do you think is k? I disagree. Kian, where's your k value? You're good. You can start doing it. You're good. You can start doing it. What do you think k is? So I'll let you catch up because you're a bit behind. Okay, checking it out. What do we say it has to look like? So pause. It has to be of the form x minus k, right? What has to be subtracted to turn into a plus 1? K is negative 1. It's the opposite. Are we missing any powers of x? X to the third, second, first, and none? Nope, we're good. Okay, I'm going to give you like a 30-second head start. My guess is that that's probably enough. I'm going to give you a moment. Don't look up at the board until you feel like you're struggling or ask. But I'm going to pause it now. Same thing, Bagley's, if you guys want to pause it and check it out, you will see a detailed walkthrough in 3, 2, 1. Check it out. If you're struggling with it, it's okay. If you're not, it's okay. It's not going to take long to do either way. What goes on the outside of my synthetic box? Negative 1. Okay, and then here's my synthetic box. What goes in this top row? And the coefficients, right? We start with the leading, and we didn't ever say it, but notice we need them to be in standard form, right? They have to be descending. So I get a 3, and then a what? And then a, boom. Okay, if you can get here, and as long as you have negative 1, we're pretty golden. I'm going to do what with this 3? Indeed, 3. Now we just start kicking. I thought you said you never bring your phone to school. Why do you need it? What are you guys doing on your phone in 6th hour? On your phone? Interesting. Who's your 6th hour teacher? Okay, I'm going to follow up with him after school. Okay. What's negative 1 times 3? No. Okay. And what do I do with them? Okay, what's 4 plus negative 3? Times negative 1 again. Now we're just repeating it, right? And that's negative 2. Zero. Okay, right off the bat, these are 3, 1, and negative 2. Do you guys get the same thing? Yes. Yell, because I see you're about to erase. What did you get differently? Or are you just holding your pencil? Show me where. Sorry. So we do. We just write it right here. Yeah, negative 1 times 3 is negative 3. Yeah. So it's now correct, right? Yeah. Okay. Change that one too. Okay. So here's the bigger part. We started with x to what power? What was our dividend's degree? Gentlemen, make sure you're here. X to the what power we started with? And now it's what? Less, right? 1 less. So check it out. Our quotient, and we'll just call this Q of x, it's a quotient, is how many x squareds? 3x squared plus how many x? 1x. And how many constant? Negative 2. Okay, follow up, just so we can tie this back to stuff. Is x plus 1 a factor of this? Was this a factor of this? How do you know? Now, we won't do this right now. Like, I lied. We're going to do it right now, but we'll just introduce it. Do we need another synthetic example? You guys ready for a curveball? Okay, I want you guys to try one for me. And let me see here. This is going to be even faster. You could do synthetic division. You could do long division. But I want us to make sure we can see if we're trying to do it synthetic, where's the problem? So let's check it out. I just want us to do one simple synthetic. Okay, here it is. I want us to know or to determine what is 2x squared. I'm going to write it a little bit differently. Plus 5x plus 3 divided by 2x plus 3. So Jade recognized it right away. And I'm going to ask him not to say it because I don't know if everybody heard him just now or not. Anybody else hear him? Did you hear what Jade said? Good. Did you really not? Cool. Well, we have division here, right? Okay, do it. Yeah. Like, can we do this synthetically? Is that the answer? No, so this is a new problem. This is C. And I've just written it. This is a different way to write division, right? Something over something also means divide. But that's the answer. So I think you're confused. Green is the answer to this problem. Yeah. But I've given us a whole new problem. I did not see that. That's fair. Yeah, no, you're good. I knew we were disconnected somewhere. Okay. Can we do this? Can we do it synthetically? I want you to look back at the notes that we made about synthetic division a second ago. What do we have to divide by? Something of what form? Keaton, go get a drink. Stand up, move, like physically go get a drink for me. Or at least walk to the water fountain and back. One of those two. But you might as well get a drink while you're there. What do we have to divide by? What form? I don't have what? Form. You're killing me, Dick. Almost. Say it again. And I was really obnoxious with mine. Check to make sure it's of the form. You're killing me, Dick. 1x minus k. It has to be. No other option. What are we trying to divide by here? 2x minus something. Is that of the form x minus k? Is it? No. So just so you know, your book doesn't do this, but I think that I'm anticipating a few of you guys in pre-calc next year, if not everybody. I don't know what you're going to take. Could I make it if I wanted to? And we're not going to do this whole problem. I just want you to see it. We could long divide. There's our first option. We could just do long division. What would I have to multiply the bottom part by to make it so it becomes a 1x? So if I multiply by 2, it'd become 4x. You're on the right track. You just answered the question differently. Divide by 2 or multiply by what's the same as dividing by 2? Give me a better number. 1/2. Now, here's the weird part, and we don't have to do this full problem, but if I mess with the denominator, I have to mess with the numerator too, because I can only multiply by 1, right? What do I need to multiply the numerator by in this situation? Good. In yellow, I've just chosen a really weird choice of 1, right? Now, in this problem, I don't know if this is easier or harder than long dividing, but let's just see what would shake out. What would my denominator become? X plus 3/2. And how about my numerator? X squared. 5/2, right? X plus 3/2. Now, in this problem, do we now have something of the form x minus k? What is k? Negative. It's the opposite. So if we wanted to do this synthetically, could we now? Yeah, we have to play the fraction game a little bit. If you guys want to do it synthetically, we can. I just wanted you to know that it existed. We could do it. Do you want to finish this problem? Okay. So check it out. I'm fine with that. I don't know if it goes in. I probably not. Or maybe. I bet it does. There will be a remainder of 0. But beyond what we need to do, I just want you guys to be aware of it, okay? Okay. Now, from this, couple random things. We're going to take a short break from division stuff. It's not really truly our brain break, but I just want you guys to help me with something real quick. Okay. I'm going to give us a function. And let's say it's f of x, and you don't have to write this down. We just talk. And I'll keep these to use here in a second. Let's say f of x is x cubed plus 2x plus 1. Can you find me f of 1? So it would really be this, right? 1 cubed plus 2 times 1 plus 1. And you might not do it out like this, or you would. Like this is how I would do it. Maybe not with 1. That's 1 plus 2 plus 1. I think it's 4. 1 plus 2 plus 1. Okay. Help me get another one. F of 5. Is this as easy? But let's try it. What's 5 cubed? I was not expecting that so quickly, but I like it. Plus, what's this one? Plus 1, and let's see, that's 136, right? Okay, let's do one more. F of negative 4. Negative 64. Minus 8 plus 1. And to me, I think it's 71, right? Okay, it gets kind of harder. Now, this function's not terrible, and the numbers aren't super bad. Would you agree? Okay, I'm going to come back to these here in just a second. Do you want a really quick brain break? Yeah. We did these random little calculations here. I'm going to drop 2 quick theorems on us. And one of them we've hit over and over and over, like I've been stressing it since the very first time we started talking about division, but I want to make sure that we can see it. Okay, for these, within our synthetic division, and it's not really just synthetic, but it's typically where they're used, we get 2 theorems that we're going to use. And I'm going to switch colors just because that's usually my thinking color. So I'll just yellow just because. So 2 theorems that we're going to see. And I want you to be aware we will see these again next year. We will use them again next year because we're just seeing them for the first time here. The first of these theorems is what's known as the remainder theorem. Okay, now we're going to check something out here real quick, and I'm going to tie it back to all this scratch work that you guys helped me do just now. If I wanted to do something with this synthetically, and you don't have to write this, I just want to show you, am I missing any powers? No. Yes. So if I were to do it synthetically, what would the coefficients be? 1 x cubed, 0 x squared, 2x, and 1. Now, hypothetically, just for fun, I want to see what happens if I stick a 5 out here. No reason. Okay, just check out what happens. 1, a 5 here, a 5, a 25, a 27, and a, let me do some thinking here. Let's see, 5 times 25 is 125. Is that right? and plus 10 more is 135. And I get 136. What just happened? When I plug a 5 into this function, my remainder was 136. What was f of 5? Okay, well, that's just a coincidence. It must be. Let's try the. Thanks, Yell. Let's try this one more time. Maybe, just maybe, it could have been a coincidence. Like, probably not, since I'm focusing on it, but it could have been. If I put in -4, any gut on what my remainder is going to be?
Probably like snakes.
That's a good guess, but let's check. 1, -4, -4, 16, 18. Must be 75, right? -77, sorry. Whoa. Yeah, 77. Whoa, 72? I was trying to cheat. I'm going to tell the truth. 4 times 18 is 72. What's the remainder? All right, well, that's just a coincidence again.
Probably is.
Or it's not, and we've just worked out a theorem. We're using the remainder to evaluate the function, right? So check it out. To find, or we can word this a couple different ways, but what we're seeing right now is the remainder theorem. There's a very clear connection, not that one, between synthetic division and these things, right? Like, it's obvious once we do it. To evaluate, or when dividing a polynomial, if some polynomial, p of x is what we're going to call it for polynomial, is divided by x minus a, then the remainder is exactly p of a every single time. Now, Deck, just in case you were zoned out, we do have a new theorem. What this is telling me, and what I will refer to this as, is I call it synthetic substitution. I can evaluate a function like this. Now, none of these are crazy hard, but what's easier, thinking about what -4 cubed is and all this stuff, or just doing this? Can we all agree the synthetic division part is easier? Like, we get the same numbers out of the deal, and I can see all the same numbers, sort of. Maybe not. Scratch that. I don't see the same numbers, but I think it's easier. There's going to be times when it doesn't really matter. Like, for one example, it's easy enough to plug it in. We could do it synthetically, but it doesn't save me any time. They're both valid. But there are situations where it does save time. This helps us to evaluate functions. All we got to do is put a outside, and it's done. Okay. As a kind of follow-up to this, the book calls it their own theorem, so I will also. We have what is known as the factor theorem. And we've alluded to this, and we've used this over and over and over in here. I've never used the language, but we've been talking about it every time. How do I connect factoring and dividing? How do I know if something was a factor?
When you're dividing, you're seeing the factors of that number.
So if and only if the remainder is what? 0. So, like, hopefully you've noticed I've kept stressing it's the remainder. What's the remainder? We talked about it, and I've mentioned it over and over and over, because the factor theorem tells me exactly the following. If x minus a goes evenly into p of x, which, can somebody tell me just another language what goes evenly into it means? If it goes evenly, what's my remainder? Remainder is equal to 0. That's all that this means. Then x minus a, and I'm just going to check you here. If I write q of x out of nowhere, what is it? Where have we used q of x? Good. The quotient. If I divide by x minus a and it goes in evenly, meaning the remainder is 0, then x minus a and q of x, or the quotient, are factors. And all of a sudden, it opens the door to us being able to factor bigger, uglier things, as long as I give you one of the factors to start. And maybe we don't even need that in the end, but if we look at any example, and you don't really have to do this example here, but we need to find one in just a moment, this had a remainder of 0. And I bet we've already done this. So let me go back up to the example we started with today. Did we do one that had a remainder of 0? B did, right? Okay, check it out. Here's my function f of x, or p of x, my polynomial. Based on what we've done here, just this thing, and you don't need to write it, here's my original function, p of x, the polynomial that I was dividing. If I wanted to write p of x in its factored form, based on all the work that we see here, is x plus 1 a factor? And this is an example we did earlier. Here's me doing the synthetic division with x plus 1. Was it a factor? What was the remainder? So if the remainder is 0, then it's a what? So is x plus 1 a factor? No, sorry, I just stopped there. X plus 1 was a factor, right? Okay. That was one of them. What was the other one? So careful, you're giving me the p of x. Hey, there it is. The quotient. These are both factors. Could I factor this one further? Factors of 6 that add up to 1? We could, right? And you might have to group it. We can. I can. I hope you can. But we're going to start factoring things using this division. Okay. Today's stuff, easier or harder than yesterday's stuff? Easier, the same. It's harder. Everybody can be different. That's all right. Check it out. Tonight, and I'm going to put it on here because I'm going to forget if I don't, you get to add an assignment or add some assignment. Now, if you're wrestling today, I want to stress to you that I know you're going to be tired tonight. I'm going to be here in my classroom till 4:30. You're welcome to hang out. You don't have to, but I guarantee I collect this tomorrow. Okay, so 4.4.2, we just did synthetic division. And it was awesome. We all had fun. You guys were laughing. We had pizza. It was cool. You guys are going to add 20 through 30 and 39. And I said do 12 too, but they're all do 12 3. Do this on one page. If you did half of it yesterday, just keep working. If you've already written on second page, you can turn in 2 pages tomorrow. I'm fine with that. Say it again. 20 through 30, yes. Cool. I know it. I don't know if it seems like a lot. It's like 11, 12 problems. But synthetic division goes quickly. Cool. All right. Sweet.